I think let me hit record. So we got Tom has discovered that he oversleeps his alarm clock 5% of the time. Perfect example for college students, right? On an important exam day, if Tom sets 2 alarm clocks, actually everybody's in here. What's the alarm clock? Don't you just use your phone? If you have 2 phones and you set both alarm clocks on a redundant alarm clock on the phone, what is the probability that he oversleeps both alarms for one? 100%. So here we have the probability that Tom oversleeps 1 alarm clock, right? So if I'm thinking about this problem, right, this is an and statement that he oversleeps the first alarm clock and oversleeps the second alarm clock. So he's got 5% of a shot, right? So oversleep, I don't know, how would I, maybe S for sleep? Probability of oversleep? I don't know, that should be like an OS or something. So the probability that oversleeps 1 o'clock is that 5%, so that 0.05. So probability that but the first case we're looking at oversleeps his first alarm clock and the second alarm clock. So we are assuming independence because the first alarm clock doesn't depend on whether he wakes up for the second alarm clock. I don't know if you can see that. I don't know. It might not. I don't know. Actually, I think it probably does have some kind of dependency. But here's another thing for the test in particular. So I don't have like how many scales out of how many scales kind of scenario. How many candies out of, can't make up a fraction really. And you might think, oh, that's 5 over 100, Andre. But I don't know how many things I have. I don't know how many times technically that denominator should be. How many times Tom has slept in his life is what that denominator should be. So I don't have that information. So if I don't have that information, and if I give you particularly a percentage, that means we don't have that information. Then I need to essentially assume independence, if that helps you for the test in particular. So yeah, it's independent, right? So we're assuming independence here. So maybe I'll try and make sure that if I ask this question, I give you a little more information about independence on this, something like this, all right? So it's independent, which means that I'm gonna do the probability that Tom overslept times the probability that Tom overslept, or the probability that Tom overslept squared, which is 0.05 squared, which is 0.0025, I believe, or 0.25%. Is another way to write that. There are 2 clocks. Yeah. 2 clocks, yeah, in this case.
I set 6 alarm clocks every morning.
Literally, it's a game that I play with myself. It's like, let's set my alarm for 5:30.
we could do this for Perry then. Very relatable then. Yeah, okay, good. Yeah, bring.
And I'm not exaggerating.
P of O and S has overslept and overslept.
Overslept, yeah.
Both
So
overslept.
they're both overslept. Yeah, so the second problem says, what if he oversleeps? What's the probability he oversleeps? 3 alarm clocks.
Yeah.
For Perry, 100%.
So same thing, but 3.
So, but 3.
Cool.
So that would be the probability that he overslept to the 3rd power, because he's got 3 alarm clocks now. So 0.05 to the 3rd power, which would be, I believe, 0.000125. You can check in your computer. I'm just. So that was the first question, and this is the second part. Yeah, sorry.
So either or answer could be the answer in the test. You would mark it right.
No, so this is, so there's 2 questions, right?
No, I mean, I'm just like for each
Oh.
problem.
So
0.05 to the second power.
if you have this, right, I will give you most of the credit, probably 9 out
But
of
you
10.
want the
But
decimal?
yeah, I want you to do that math.
Okay.
Right? You got GeoGebra, you got maybe another calculator can do it.
So for the questions above, is it okay if we just leave the fraction or do you want the decimal? No,
I would want the decimal, yeah, because that's an ugly fraction. Nobody would, you would not like report that out to anybody in any way, shape, or form, right? If you were like doing a study on the scales kind of thing, that would be not the number you share with your boss, the whole big fraction. You would share the decimal. Right. So, but again, right, you give me those fractions, you understand the problem, you're gonna get most of the credit. Right? So that's how I think about it. Right, and then I didn't say this, but I've said it in my other class, and I think about it, right? So you want to show me some of this work too, right? Not necessarily, you don't necessarily have to write out this confusing notation if you're not sure what I'm saying, to help you understand what this is saying, right? But show me some steps, right? Because if you mess up in your calculator and you just write down that number for me, I can't give you any partial credit, right? I can't give you any partial credit, so I can't do it about it. Right? But if you show me the steps, then I can give you some partial credit. I got to think about that if we go online too, how I can incorporate that into it somehow. Okay. Some are. Yeah, we talked about it at the beginning of class too. So if you want to talk to me after class, if you didn't get that, we can talk about it too. So we're thinking about it, right? We're not there yet, so we're assuming the test will be on. You want me to hit it?